everyone, welcome back to the channel. Today we're going to be discussing a pressing environmental issue, PFAS, or what many are calling forever chemicals. These substances pose significant risks to our soil and water, but there's a hope on the horizon. Recent research by Dr. Yi Chang and his team has provided an innovative solution using electrothermal mineralization. Let's dive into this topic. Okay, so what are PFAS? PFAS stand for para- and polyfluoroalkyl substances. These man-made chemicals are popular in many products due to their water and grease-resistant properties. However, what makes them useful and also makes them problematic is that they don't break down in the environment, hence the term forever chemicals. Okay, now what's the significance of PFA pollution? Well, PFA pollution is a growing concern. These chemicals contaminate our drinking water, lead to severe health problems such as cancer, liver damage, and developmental issues in children. Understanding and addressing these problems is crucial for both protecting our health and our ecosystems. Now let's get into the research behind this. Enter Dr. Yi Chang, whose groundbreaking research focuses on soil remediation of PFAS. His study, published in Nature Communications, showcases an innovative method, electrothermal mineralization. Let's see how this process works and why it's so significant. Let's dive into the experiments conducted by Dr. Yi Chang and his team. They performed a series of tests to evaluate the effectiveness of the electrothermal mineralization process on various PFA compounds. In their experiments, the researchers collected contaminated soil samples containing differing concentrations of PFAS. They then subjected these samples to the electrothermal mineralization process. This involves applying heat and electric energy, which catalyzes the breakdown of the PFA compounds. The data from these experiments showed a remarkable reduction in PFA levels, with some compounds being broken down by over 90%. The researchers used mass spectrometry to analyze the transformation of these harmful substances into non-toxic products, confirming the efficiency of their method. I don't know about you guys, but I'm definitely more of a visual learner, so I created an infographic of the electrothermal mineralization soil remediation process. So first you have your biochar tank that kind of mixes the biochar around to prepare it to be added to our contaminated soil. After that, you have the REM treatment. You have those insulating caps going down into the ground, applying electricity to the soil, creating remediated soil. So that's a visual representation of how the process works in case those words just weren't really working for you. And then here I have a before and after the REM process of those insulating caps going into the ground, just so you can really see how much electricity is going into remediating this soil. Okay, but why are these findings even significant? Well, they demonstrate that not only can PFAS be broken down effectively, but that this method can potentially be scaled up for wider application. The results align with growing concerns about PFA pollution, emphasizing the need for innovative solutions in environmental remediation. By sharing the data and outcomes from these experiments, we can begin to understand the profound implication that this research may have on our efforts to combat PFA pollution in our environment. By using this technique, Chang's research provides a tangible solution to an otherwise daunting problem. These findings have the potential to restore contaminated environments and safeguard public health. This research not only addresses an environmental crisis, but also ties back to the concepts we've studied in Chem 113, like chemical reactions and soil chemistry. The application of electrochemical methods exemplifies how chemistry can solve real-world problems. As for future research, studying the long-term effects of these treatments on soil health would be extremely insightful. There's definitely enough data to support the claims made by Dr. Yang and his research team. A negative is that there's not a lot of other scientists replicating this data just because it is so unprecedented, it's so modern that there's not a lot of other data besides Dr. Yi Chang's data himself. To make a difference, we must support efforts like Dr. Chang's advocating for funding research in PFA remediation and informing our community about these critical results. Together, we can work towards a healthier planet. Thank you for tuning in. If you found this video informative, please like, share, and subscribe for more content on environmental science. Let's keep the conversation going in the comments below.